At this very moment, assuming you are sitting perfectly still, you are actually traveling eastward at roughly 1,600 kilometers per hour. That is the rotational speed of the Earth at the equator. If the planet instantly hit the brakes, the principle of inertia dictates anything not firmly bolted to bedrock would keep moving at that speed. The atmosphere would maintain its eastward momentum, generating supersonic winds at the surface. These currents would exceed 1,600 kilometers per hour, stripping away buildings, trees, and topsoil, reducing the land to bare rock in minutes. The oceans, carrying massive mass and momentum, would surge eastward as well. These continent-drowning mega-tsunamis would effectively erase every global coastline. But if you move 20,200 kilometers straight up into medium Earth orbit, the chaos disappears. In the vacuum of space, there is no wind and no water to carry the kinetic release. The entire GPS satellite constellation just continues gliding along its orbital paths, completely untouched by the catastrophe below. The satellites retain their power, their solar panels are still oriented, and broadcast precise atomic time. Yet, on the surface, the navigation system they support fails within minutes. The survival of the orbital hardware only highlights the fragility of its code. Our entire digital infrastructure is mathematically tethered to the physical momentum of the planet. To understand why the system breaks, we have to look at how GPS maps the space between the orbit and the ground. The system operates by reconciling two different spatial coordinate systems. First is the non-rotating Earth-centered inertial frame, the ECI, where satellites orbit and signals travel in straight lines. Inside sits the Earth-centered Earth-fixed frame. Pinned to the surface, it rotates alongside the planet, acting as the map we use to find our position. It takes a GPS signal about 60 to 80 milliseconds to reach a receiver. This diagram shows the core logic. Distance equals the speed of light times the time delay. But in that short flight time, the Earth physically rotates away from its original position. To fix this, receivers use the SAGNet correction. This is the specific rotation matrix, labeled equation 4 here, hard-coded into GPS firmware. It is a relativistic offset that compensates for the Earth's spin while the signal is traveling through space. When the Earth stops, the physical rotation creating that delay vanishes. But billions of smartphones and aircraft don't know that. Their software blindly continues applying the rotation math to a stationary world. This table shows the mathematical drift that follows. By continuing to apply a rotating correction to a stationary planet, your calculated GPS position begins drifting across the map at up to 1,600 kilometers per hour. This drift corrupts the precision timing that critical infrastructure relies on. Modern power grids use phasor measurement units to monitor electrical phases across the continent, requiring synchronization to within 1 microsecond. This timing is provided by the GPS pulse per second signal. When the receiver's clock fails to account for the lack of rotation, that microsecond accuracy disappears, triggering a systemic desynchronization of the entire grid. The result is a total decoupling of the digital and physical worlds. Our civilization's technological brain remains active in orbit, but it is speaking a language of rotation to a world that has stopped moving. Over centuries, the chaos on the surface transitions into a slower, geological restructuring. Without the force of its spin, Earth's physical form begins to settle. The Earth currently has an 8-kilometer-high bulge of water at the equator, held there by centrifugal force. When that force disappears, gravity takes over. The oceans drain toward the poles, revealing a massive, continuous equatorial megacontinent and pulling into two giant circumpolar oceans. The Coriolis effect vanishes, meaning atmospheric patterns lose their curve. Swirling weather systems like hurricanes and trade winds are replaced by simple convection loops, with air moving in straight lines between the equator and the poles. Deep within the planet, the loss of rotation triggers a final, silent catastrophe. The liquid iron in the outer core no longer swirls in structured columns. The geodynamo that generates Earth's magnetic field simply stops. Through ohmic decay, the magnetic shield dissipates over thousands of years. Without it, solar radiation is free to strip away the atmosphere, leaving the planet exposed to the vacuum. Because the Earth still orbits the Sun while its own rotation has ceased, a single solar day now lasts an entire year. Any given location must endure 6 months of continuous, scorching daylight, followed by 6 months of freezing darkness. High above this scoured, irradiated world, the GPS satellites remain. Using star trackers to maintain their heading, they continue to broadcast perfect atomic time and coordinate transformations into the silence. They become a digital relic of a dead world. Our greatest technological achievement ends up speaking a language of rotation to a stationary void, proving that our modern existence depends entirely on the steady, unseen spin of the Earth.